Hello, it's Mr. Serrano here. We know how to get into the FSA online practice. The website is fsassessments.org. You can choose families and students and take the practice test right there. We're going to quickly try to go to the first 9 questions or so. Here we have an expression shown with exponents. This is a multiple choice, so nothing but to click the right answer. We notice here that on the top, we're adding 2 elements that have the same last name times 10 to the negative 5. So we're just adding 4 of those. 4 plus 2 from this section. There are like terms, the last time is the same. So this will give me 6. The last name is times 10 to the negative 5 over 3 times 10 to the 7. Sorry for my blurry screen. Supposed to be at 10. So 6 divided by 3 is 2, which is the format that we have. And then we have 10 to the negative 5 divided by 10 to the negative 7. So when we divide powers with the same base, what we have to do, sorry, there was a 5 in there and a 7. So what we have to do is leave the base and subtract the exponents. So that will give me a negative 5 minus 7, which of course, as we know, we don't truly subtract because they have the same signs. So if I owe you 5 and I owe you 7, from 2 different locations, I owe you 12. So this is 2 times 10 to the negative 12. And that should be my choice. Next question, let me clear all that. Select all the sequences of transformations that always maintain congruence. So the only one that does not maintain congruence is the dilation. Dilations are similar, but not congruent. So we want to maintain congruence. We don't want to pick anything that has dilation in it. So we do not choose that. We do not choose that. We do not choose that as they have dilation. So to answer correctly, I choose the first 3. Moving on. Clearing. Okay. So multiplying powers with the same base. 3 to the m, this is a number, times 3 to the n. So which 2 numbers, m and n, when I combine them, combining like terms, are going to give me 3 to the negative 2. Well, any 2 numbers in which at the end, I owe you 2, such as this could be 3 to the negative 5 times 3 to the positive 3. This turns into 3 to the negative 5 plus 3. Remember, we're multiplying powers with the same base. The base is 3. We add or combine the exponents, keeping the base. So I'm keeping the base, and a negative 5 and a positive 3 give me a -2. So, and you can find any pair, any two numbers with a difference of 2 where the larger number has the negative sign. So let me see. So we can use this tool right here at the bottom, -5, and over here 3. That's how we use that, and we clear everything and move on. Okay, here says that a pentagon is shown. Translating 5 to the left. Remember that in this case, we have to just move each point 5 units. 1, 2, 3, 4, 5. So we don't count the beginning. This is like Monopoly. Once you move, make a step, you count 1, 2, 3, 4, 5, and then reflect it over the x-axis. That means we're going to fold this hamburger side along the x-axis. So this point, when I fold it, has to match the reflected point. So if this is 2 away, the next point has to be 2 away, kind of like battleship. You're trying to match your point with the point on the other side. And so using these tools, we have adding points. So that's the original translation. And the connect line right here allows us to do just that. Connect lines between 2 points. And so that's our answer. Okay, a relation that is not a function. We know the rule is that to be a function, the x values cannot repeat. In other words, they cannot be paired with 2 y values. So if I have 1 input and an output of 2, that's it. 1 has only 1 output. I cannot use 1 again with an output of 3 because that is not a function. So that's exactly what I'm going to type right there. So if I put a 1 here, that has 1 output 2, 1 cannot give me any other output. Let's say the function was add 1 to the value of x. So if I add 1 to 1, it's going to be 2. It's not going to be 3. And it's not going to be 7 or anything else. Let me clear my drawings. Okay, rational or irrational. If I get a whole number, the square root of 81, is 9. So 9 is a whole number. So that's okay, that's rational. 89, that's not gonna give me a whole number when I take the square root, so it's rational. The square root of 121 is 11. So that will work. And then the square root of 131 is going to be an irrational number. And so I will click that. Once I explained it, I can now click. And then clear all drawings. And go to the next question. Number 7. I think it's time to make a pause for the first 6 questions, and we will make another recording from here.